For today's presentation, my group will present about instrumentation report. So my group, which is group 7, consists of 4 members, which is me, Muhammad Haikal Osman, Muhammad Hasib bin Sufri, Suharau Khan Alatis Farau, Elif Badis, Muhammad Haizat bin Muhammad Kamal. So without further ado, let's start.
Hi, I'm Sumal Rao. I'll be explaining the instrumentation of identification symbol. There are consists of 4 line tracing activities that we have found during this project, which is the electric signal, which has the symbol of dotted lines, and then the removable spool, and process flow, which is the thick black line, and then lastly the generic piping connection. So going to the flow connection indications, there are 6 types of indicators that we have found, which is the first one Fi, which is the flow indicator, Li level indicator, Pi pressure indicator, Fic flow indicator controller, level indicator controller LIC, temperature indicator controller TIC. The next one will be the plant machinery equipment symbol. Basically, there are 9 plant machinery symbols that existing in the instrumentation PNID. So we have classified into a table where there is the equipment on the left and the function of the equipment on the right. So the first one, pump and compressor. It has the ability to move liquid or gases to be compressed. So the next one, plate and frame heat exchanger. So what it does is it creates high turbulence and high wall shear in the heat exchanger, which lead to a high heat transfer coefficient and a high falling resistance. The fluids travel within the heat exchanger. So the third one is the straight tube heat exchanger, where the one fluid flows through the tubes and another fluid flows over the tubes through the shells to transfer heat between the two fluids. The fourth one is going to be the mixing tank, where it mixes the combination of components together, such as plastic, strong rubber, and glass, to allow heat and mass transfer to occur. The fifth one is the measuring tank, where it measures the liquid volume of the tank. There are tray distillation column, which used to carry out unit operation where it is necessary to transfer between two phases, the liquid phase and the gas phase. And then the cartridge filter. Cartridge filter is to remove unwanted particles, pollutants and chemicals from the liquids which is flowing through. And then the steam injector. Steam injector is normally extracts air and other non-condensing gas to maintain vacuum, which corresponds to ratio of cooling water quantity, cooling water temperature and cooling surface. And then last but not the least, the stripping column. This stripping column is where physically separates the components from a liquid stream by a vapor stream. We have loop number 6 PNID diagram, and then the description of loop number 6, which classified into a table. The first one is the control objective of the system. So in this system, for loop number 6 is to control the temperature in the heat exchanger. So the control configuration is going to be the feedback configuration, because it fed back to the input. So the control in the system is to maintain the amount of heat exchanging in between the heat exchangers. And then the measured variable is to control the temperature in the heat exchanger, which is the same as the control objective. So in the loop number 6, it manipulates the inlet flow rate of cooling water. There are no disturbance in the loop number 6. And then the most suitable sensor that can be used in this this loop is the resistant temperature detector because it has the rapid sensitivity and high long-term stability. In my opinion, the most suitable valve that can be used in the loop is a globe valve because it regulates the flow in a pipeline efficiently and effectively.
I will start with the first loop. The first loop as shown in the figure. As we can see, the control objective for this loop is to control temperature of oil that leaving heat exchanger. The control configuration for this loop is feedback control loop. Control variable and measured variable is same, which is temperature of oil that leaving heat exchanger. The manipulated variable is flow rate of feed steam. The disturbance is temperature of feed oil from heat exchanger. The most suitable sensor is resistance temperature detector, or also known as RTD. The reason RTD is the most suitable sensor because RTD has good stability, excellent accuracy, contamination resistant, good linearly, area temperature sensing, and very repeatable temperature measurement. The most suitable valve for this loop is gate valve. The reason gate valve is the most suitable valve because a gate valve is a valve that has dual flow direction. It is suitable for use in the pipeline where the medium may change the flow direction. The second reason is the flow resistance of the valve is small. And the last reason is the range of application of gate valve is wide. It can also be used as a venting valve and a low vacuum system valve. The second loop is shown as in the figure. For the second loop, the control objective is to control flow rate of feed steam that entered the deodomizer. The control configuration is feedback control loop. Control variable, measured variable and manipulated variable is same, which is flow rate of feed steam that entered the deodomizer. The most suitable sensor is vortex meters. The reason vortex meters is the most suitable sensor because vortex meters has a wide range ability and insensitive to variations in density, temperature, pressure, and viscosity. The most suitable valve is gate valve. The reason gate valve is the most suitable valve because a gate valve is a valve that has dual flow direction. The flow resistance of the valve is small and the range of application of gate valve is wide.
Okay, so for the loop number 3, moving on to the loop number 3. Moving on to the loop number 4. So for this loop,
Okay, so for the loop 5, I will explain to you. Okay, first the control objective of the loop 5 is to control the level inlet stream to the bottom of the streaming column. And the control configuration for this loop is feedback controller. And what is a control variable? So the control variable is the level inlet stream into the bottom of the streaming column. And what is the measure variable? The measure variable is the level inlet stream into the bottom of the streaming column. And the manipulated variable is the flow rate inlet stream into the bottom of the streaming column. And the disturbance of this particular loop is the pressure of the inlet stream into the bottom of the streaming column. And the most suitable sensor we suggest is the pressure level sensor. And why pressure level sensor? It's because of level indicator is to be installed at the bottom of the streaming column, which will be accurate if pressure level sensor is used because it relates the density of the oil, we take of the oil in the column. And the most suitable valve is valve valve. Okay, the justification of regulation of fluid flow, shut off service of fluid, can also be able to handle collected fluid and service. So for the next loop, I will pass to my other companion.